name is Lynn Gacheri from Dedan Kimathi University of Kenya in the Institute of Geomatics, GIS, and Remote Sensing. My topic is modeling the implications of climatic, biophysical, and anthropogenic activities on river sedimentation, a case study of the upper Ewaso Nyiro River Basin in Kenya. On the introduction, we know that the river basins are very important, therefore the quest to really protect them. Okay, so the soil conditions of our basin strongly depend on these hydrological conditions, as well as the biophysical conditions, and also the biological diversity. So the changes in the soil affect and challenges the natural resources, and therefore leading to high sedimentation rates, which may further lead to low agricultural productivity. So the Ewaso Nyiro River Basin is the largest in Kenya, and it is suffering from soil sedimentation rates. So these extreme climatic events and human interferences have led to increase in both runoff and the sediment to the river systems. So the soil sedimentation of the Ewaso Nyiro River Basin, if studied, could help understand the natural dynamics of the process, and this will be important for the evaluation of the socio-economic and the environmental impacts which necessitate the soil sedimentation. The problem statements, due to the varying climatic variabilities and the human activities, the increased soil sedimentation rates of the region pose a threat to the river basin. This also poses a threat to the natural availability of these Ewaso Nyiro River Basin. By doing that, it has negative impacts to both the local, social, and the economic development of the basin. These has impacts on the pastoralism, ranching, and even agriculture. A very good example is one of the counties in the river basin, the Laikipia County. It has more than 75% of the household income relying on agriculture, and of course this employs more than 60% of the county's population. So it is therefore urgent to assess this specific problem. On my objectives, the general objective was to model the implications of climatic, biophysical, and anthropogenic activities on river sedimentation. The specific objectives, the first one is to evaluate the climatic, biophysical, and anthropogenic variables that influence sedimentation from 1990 to 2020. Then the second one was to model the sedimentation rates using the modified ASO model, the muscle, and then to predict the future scenario of the river sedimentation by 2030 using the CA Markov chain analysis. So this is the study area map. The upper Ewaso Nyiro River Basin covers an area of roughly 15,200 kilometers squares, and it has been experiencing a very high population growth, arising mainly due to the immigration and also the nomadic pastoralist. Again, I give an example of the Laikipia County. The population has tripled over the last 3 decades. Right now in 2009, it was roughly 399, 227 people. Also, it is also a rich in wildlife ecosystem and a home to a large wildlife and livestock population. So these were some of the data sets that I had. I used Landsat from USGS with a 30-meter resolution to be able to get my soil moisture, lineament density, NDVI, and land use land cover. I also used the DEM from Alaska Satellite Facility. It is a 30-meter resolution resampled to 12.5 resolution. I also had the rainfall data, soil data, as well as the questionnaires that aided in my fieldwork. It's not really clear from here. So I had several data sets. The first one was the rainfall data, the DEM, the Landsat, and also the soil, as well as the interviews. From the DEM, I was able to get the slope and the flow accumulation, which gave me the LS factor. And then from the Landsat, I was able to derive the soil moisture. I was also be able to come up, perform the classification and acquire my land use land cover maps. From there, I was able to come up with the safe factors. I also use the NDVI as my management data. That is the P factor from from the Landsat. So I also had the soil. I was able to come up with the geological soil groups, and then of course I was able to derive the K, or the heritability factor. So all those factors were the requirements for the modified soil parameters. But because I was using another model, I had first of all to delineate my watershed. So I used the HEC Geo HMS model. That is the hydrological engineering sector, hydrological modeling system, or the geological system. So it was able to delineate my watershed, and also be able to come up, I narrowed down to 4 sub-basins. So when I came to the modified ASO parameters, now I used another model, the HEC HMS now. So I was able to input my parameters. and I was able to attain the river sedimentation using the HEC HMS model. But for me to be able to predict my data for 2030, I used the MAT criteria evaluation. So I had the factor standardization. Of course, I was able to give the weights according to the interviews. So I did all that. I did the aggregation of all the suitability maps. Then I was able to do the WSC aggregation and came up with the several suitability maps. And then, of course, I ended up with just one suitability atlas. When I came to the modeling, the CA Markov, the river sedimentation, that is from my HEC HMS, that is from 1990 to 2020. I was able to put it in the Markov. I was able to come up with the probability matrices, the contiguity filter of 5 by 5. So I was able now to be able to get the results of 2020. I first of all predicted for 2020 in order to validate my model. From the results, then I'd be able to tell if I should continue with the prediction to 2030. So I had to validate my model first. So these are some of my results, the land use land covers. My research was from 1990 to 2020. I had roughly six classes. I had the forest and the bare land. I had the cropland. I also had the water bodies, the grassland. So you can be able to see how they have been changing over the time. I performed the accuracy assessment of the land use land cover maps, and I was able also to be able to represent them in terms of graphs. This was the soil moisture that was extracted. So it had the values ranging from, in my case, 1. So the higher soil moisture, of course, it leads to the high rates of sedimentation and vice versa. So the lineament density, we know that the lineament density indicates areas with high water content, and of course this also leads to high sedimentation rates. So they had to reclassify my data into 4 classes, with from very high to low sediment yield. We also had the NDVR, so I did for the 4 decades of the 3 epochs. So and the values, of course, ranges from 1 to -1. So the K factor, or the soil erodibility factor, it was described the resistance of soil erosion and depends on soil properties and particle size. So it ranges mine from 0 to 1, with 0 indicating areas to high susceptibility to soil sedimentation. I also went ahead and derived the LS factor. So it depended on the length and slope of the terrain. So the lower values of the LS factor indicated the flat slopes, while the high values indicated the steeper slopes. I also had the C factor, which is the impact of the land cover to soil sedimentation. It ranged from 1 to 0.0001. For example, 1 indicated bare ground, and of course the bare ground means that we have low soil sedimentation. We also had 0.1 indicating thick vegetation, resulting to the high sedimentation, So these are the results of the HEC HMS. I said HEC, it's the Hydrological Engineering Center, Hydrological Model System, the HEC HMS. So I was able to delineate or come down to only 4 sub-basins in the entire river basin. So I had 4 of them. So these results showed the peak discharge on the highest time of the peak of that river. So I went to each and every sub-basin. They had names. The first one is the sub-basin W1 and 10. So this is just shows the relationship between the depth and the flow. So I did this for the 4 sub-basins that I had. Then after this, I was able now to go to my second objective, which was the sediment load. So according to, for example, the sub-basin W110 and sub-basin W1000, they had very similar characteristics. Like for example, in April, both in 2020, the yellow one is in 2020, it had around 500,000 tons. When it came to W1000, the same time, it had 700,000 tons. Meaning that this sub-basin is larger, of course, but it also has high rates of sediment load. So, and also the other two, which is the sediment sits 70, and the sub-basin sits 70 and 780. So 780 and the lowest sediment loads compared to the other first two. And of course, most of these high sediment loads were experienced in the month of April in 2020. So I went ahead to represent my data spatially for move maps to be able to know the progress or the consistency of these results. So from 1990, this is done in color red. It was sub-basin 1000, and it had the highest sediment load because, of course, you have a lake here, Lake Olsobot, or Olbosot, forgive me the name. So we have this one having the high sediment load in 2020, followed by this other one. Then I had the 1000 here, and then finally I had the 780 sub-basin. So if you realize from 1990, 2000, and 2020, they were consistent. But when it came to 2020, the 670 and 1000 kind of interchanged. So this one does not became the highest, or this is very high, this is high, medium, and still maintained to be the low. So from these graphs here, I can be able to tell that these two, if I can say color yellow and gray for 2010, interchanged from color yellow and gray in 2020. So the color yellow here, or this sub-basin, had a lower sediment load compared to the gray one. But when it came to this other one, also they interchanged. So when I came to the Markov-C analysis, I had first of all to validate my data. So I predicted first of all for 2020. So I compared now, this is results from the HEC HMS, and this is the predicted results from the MC analysis. So the validation showed a good agreement between the observed and the simulated maps in 2020. The evaluation between accurately classified, so I had accuracies. I had the location accuracy or the no accuracy, which was 0.94. I also had the accuracy to specify or location correctly, the K location was 0.98, and the strength or to specify the quantity, which is the location structure, was 0.98. So the ability of the model predicted to attain complete classification, the K standard was also 0.93. So this means the kappa statistics between the observed and the simulated gave us score of 0.9, therefore validating the MCA model. So I was able to predict my river sedimentation for 2030. So in this one, the W110 still maintained to have the highest sediment load, followed by W1000. Then I had 670, and finally the 780 still maintained to have a low sediment load. In conclusion, so this study proved that the river basins are really being affected due to the varying sediment loads, and the failure to regulate the current land practices will greatly affect the nature and the productivity of the river basin. It is recommended to use the HEC HMS for the river sediment load analysis, as it showed great consistency in the results. It was able to show results both from the pervious and the impervious areas in the river basin and routed to the streams. Also, the projected results can be used to address the problem by regulating the anthropogenic activities on the river basin. It can also be used to the policymakers to help them mitigate the problem. Stakeholders like NEMA, for example, could use the results to advise and provide guidance on the implementation of environmental intervention. Thank you.
Thank you very much, Lynn, and thank you for your presentation. One observation that I saw within your data sets, there are some data sets that were at 12.5 meters and others were around 30 meters. So what was your final resolution for your models?
So for the 30 meters were the Landsat data, which was the 30 meters. But remember now for the DM, it was 30, but we sampled for 12.5 to end in the analysis.
Yeah, thanks, Lynn, for your good work. Just a quick one related to the previous question. Now that we have Sentinel that is freely available, how do you think that would impact on your work? I know you've used Landsat, that is 30 meters. We have Sentinel, which is 10 meters. Would there be value in exploring it, either in your work or some other work?
Okay, thank you for the question. I didn't really explore Sentinel because I was going back to the 1990 studies. So I realized I can't really meet the result for Sentinel and Landsat because I was going to 1990. So I think when you explore, because it has a higher resolution, maybe it can be able to improve the results.